Hello, this is Mr. Yoon. Today we are going to be learning about square roots. And today's key phrase is that square root of non-perfect squares are irrational. Now, I know that you don't know what the meaning or the definition of a lot of the words in the key phrase yet, but I will explain just in a second. So, here are some key vocabularies that will be used in this lesson. First is square. In this case, for throughout this lesson, square will not mean the shape where all sides have the same length. In our situation, for this specific lesson, it will be used as power of 2. So for example, over here we have 3 to the power of 2, but it can also be read as 3 squared. And the next definition is rational numbers. Rational numbers are pretty much whole numbers, negative numbers, zero decimals, with ending or patterns, and fractions. So for example, 1.4 is a rational number. 3 over 4 is a rational number. Negative 7.4 and negative 3 are all rational numbers. Then there's also irrational numbers. And those are pretty much decimals without end or pattern. And the most famous example of irrational numbers are pi and square root of 2. If you plug these two numbers in calculator, you'll find that pi is 3.1415 blah 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 without any specific pattern or an ending. And also, if you put square root of 2 into your calculator, you will get a decimal that will not have any ending or pattern. And now, what is square root of 2? We will talk about it more in this lesson. And here are a couple more definitions on the back. So perfect squares are square of rational numbers. So for example, 1 is a perfect square because 1 squared is 1. And 4 is a perfect square because 2 squared is 4. And 9 is perfect square because 3 squared is a 4. 3 squared is a 9. 1.44 is a perfect square because 1.2 squared is a 1.44. And 9 over 4 also is a perfect square because 3 over 2 squared is 9 over 4. And next is square roots. So I will talk about square roots in more detail, but for now, you can think of square roots as opposite of squares. So over here, and we use the symbol over here. So this is read as square root of 4, and we know that 2 squared is 4. And as I said before, opposite of square is a square root. So square root of 4 is 2. And square root of 1.44 is 1.2. So here is our times table. And let's try to figure out how to use times table to figure out perfect squares and square roots. So here, if you look, square means that we are going to be multiplying the same number by itself. So here we have 1, and here we also have 1. So 1 times 1 is equal to 1. So 1 is a perfect square. And here's 2, and there's another 2. So we know that 2 times 2 will give me a perfect square of 4. And then here's a 3 and another 3 here. So then there's 3 times 3, which will give me 9. So far we know that 1, 4, and 9 are perfect squares. And actually, in fact, that all the numbers on the diagonal of the times table will give me perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144 are all perfect squares of whole numbers. And something that is interesting about looking at the perfect square from the times table is that if I actually draw a little box starting from this corner here, is that if I, for example, if I have 4 here, to the corner, then I have actually a 2 by 2 square that has 1, 2, 3, 4 boxes in it. And that pattern also follows for other numbers as well. So for example, if I draw a slightly bigger rectangle going up to 9, then I get length 3 by 3 rectangle that has 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers in it. So back then, long time ago, when in the ancient times, when people asked for squares, they meant they are trying to get area of the square. Okay, let's move on to how to figure out square roots of perfect squares. So keep in mind that square roots are opposite of squares. So we figured out perfect squares by finding a number that where two of the same numbers was multiplied. So trying to figure out the square root of a perfect square, first we find the number, the perfect square on this diagonal. If a number is a perfect square, it will be on this blue line. Then, for example, let's try to figure out what square root of 64 is. So here is our 64. Then we know that square root of 64, which will be written as, with a little symbol here, square root of 64 will be, we can either go up or to the left, there should be a same number. And then we know that square root of 64 is going to be 8. So let's revisit our key phrase. So the key phrase for today was that square root of non-perfect squares are irrational. So now let's think about what that actually means. Over here, we know that squares are numbers that are being multiplied by itself. So 1 times 1, which was 1, is a perfect square. And when the two numbers are whole, we get a perfect square, which are the result. So 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, and all the numbers on this blue diagonal are perfect squares. And we can find its square root by going up to figure out what number it was that got multiplied by itself to get to the original number. And if you notice, there are actually a lot of gap in between all these numbers. So in between 1 and 4, there are some numbers missing, like 2 and 3. Or in between 4 and 9, there are some numbers missing, like 5, 6, 7, and 8. So those numbers are what we call non-perfect squares. So when we try to square root them, we will actually get an irrational number, meaning that it will be a decimal that does not have any pattern or an ending. And we will learn more about what to do with those cases next class. Thank you for watching. Feel free to ask questions if you have any.